Great minds all over the world have been wondering since time immemorial what consciousness is and where it came from. Today, this topic is increasingly occupied by physicists, cognitive scientists, and neuroscientists. There are several prevailing theories. The first is the materialistic one, which assumes that consciousness originates from matter due to the impulses of neurons inside the brain. Take the brain out of the equation and consciousness doesn't exist at all. Traditionally, scientists have been staunch materialists, but they had to face the limitations of materialism. By imagining the gap between relativity and quantum mechanics or Heisenberg's uncertainty principle, one can see these inconsistencies. The second theory is the dualism of mind and body. It is most often characteristic of religious thinkers. Consciousness is separated from matter. It is part of another aspect of personality, the soul, in religious terms. This is followed by the third option, which is gaining popularity in some scientific circles, panpsychism. According to this point of view, the entire universe is inhabited by consciousness. So far, few scientists take this theory seriously, but it is causing heated debate. In truth, panpsychism is very similar to what Hindus and Buddhists call Brahman, a huge universal deity of which we are a part. In Buddhism, consciousness is generally the only thing that exists. If a tree falls in the forest and no one hears it, does it make any sound? The point is that everything we experience is filtered and interpreted by our consciousness. Without this, the universe does not exist at all. In some circles of physicists, the theory of a peculiar field of proto-consciousness prevails. In quantum mechanics, particles do not have a definite shape or a definite place until they are observed or measured. The scientist and philosopher John Archibald Wheeler believed that every part of matter contains a little consciousness, which it receives from this field of proto-consciousness. He is known for coining the term black hole. Wheeler called his theory the anthropic principle of participation. She argues that human observation is the key to the whole process. We are involved in creating not only what is here and now, but also what is far and long ago. In his opinion, which is similar to Buddhist views, nothing exists until there is a consciousness capable of comprehending it. Neuroscientist Christoph Koch of the Allen Brain Institute says that the only theory about consciousness that exists today is that it is a level of awareness of oneself and the world. Biological organisms are conscious because when they get into a new situation, they can change their behavior to cope with it. British physicist Sir Roger Penrose suggested that consciousness exists at the quantum level and is located in the synapses of the brain. He is known for linking consciousness to some developments in quantum mechanics. In his opinion, the laws of physics generate complex systems, and these complex systems lead to consciousness, which then generates mathematics, which in turn can encode in a capacious and inspiring way the basic laws of physics that gave rise to it. The launch of the European Space Agency's Gaia telescope, which makes up the star map, may provide more data for or against this point of view. It is believed that dark matter makes up about 95% of the entire universe, although scientists have not yet been able to detect it. So, theoretically speaking, if consciousness is a property that arises at the subatomic level with the fusion of particles, how do these tiny pieces of consciousness connect? Neuroscientist and psychiatrist Giulio Tononi from the University of Wisconsin suggests a slightly different approach to panpsychism, which is called the theory of integrated information. Here, consciousness is a phenomenon that has a real, physical place in the universe. We just haven't found him yet. Perhaps this celestial body radiates consciousness in the same way as our sun radiates light and heat. He even offers a criterion for measuring how much consciousness there is in things. This unit measures how much a creature can exercise control over itself or around itself. This theory separates intelligence from consciousness, which some people equate to each other. Take artificial intelligence, for example. He can already beat people in a variety of tasks, but he has no will of his own. A supercomputer that can make changes in the world without programmer commands will be conscious. Therefore, the question arises, can the universe be intelligent? First, let's define what the mind is in terms of mechanisms. What can intelligent beings do that unintelligent ones cannot? Let's compare the simplest bacterium with a human. What is the difference in their behavior at a fundamental level? The most obvious thing is that both bacteria and humans can analyze the environment and adapt to it, but humans have a much larger range of possible reactions and, accordingly, have the opportunity to choose a more optimal one. What determines the width of the spectrum of actions? Of course, the width of the spectrum of incoming signals and the algorithm of their processing. The deeper and more detailed the analysis of the environment, the more information about trends and events can be extracted from it. And since a person thinks very flexibly, forms of analysis with a long-term perspective and taking into account a huge number of parameters are available to him. The more complete the analysis, the more intelligent the creature is. And what is analysis? This is information processing, that is, calculations. And this means that any intelligent being is a calculating mechanism, that is, a computer. Each cell is a primitive computer that tries to calculate an adequate response in response to the state of the environment and the internal state of the cell itself. It's the same with the brain, but it's already a computer with a lot of power and capabilities. Of course, classic computers will also fit this description. However, they should be considered not as separate intelligent entities, but as additions to the human mind, a kind of additional intellectual limbs. Now let's move on to the physical laws, namely the second law of thermodynamics. It says that in an isolated system, entropy, that is, a measure of disorder, increases over time. In other words, a system without external influences tends to a uniform distribution of energy and matter, which means that it is becoming increasingly difficult to predict exactly which microstate is observed in it at a particular time. That is, uncertainty is growing. And when uncertainty grows, its opposite, information, decreases. The state of the system with the lowest entropy on the example of the simplest space of two halves. It is absolutely known about each indistinguishable ball that it is on the left. At the same time, it is obvious that computers are increasing the amount of information. Calculations make it possible to reduce uncertainty from a wide range of possible answers to choose one specific and most appropriate one. Does this contradict the second law of thermodynamics? Of course not. A computer is not an isolated system at all. Its calculations require energy from the outside, and due to the large increase in entropy around, computers can reduce it in the local neighborhood. The computer itself is always a rather complex system, which means that its creation also requires energy and matter. And what is the most complex structure in the observable universe? This is life. And she is just able to build complex structures with low local entropy. All computers, even in the broadest sense of the word, were created exclusively by living beings, people. In other words, only life can consistently create computers, and the more complex a computer is, the more complex a computer it can create. Creating computers is a key part of life because it is adaptability that allows living beings to survive and leave offspring. The entire evolution of the biosphere was aimed at increasing the complexity of calculations, which ultimately led to the emergence of a modern human civilization. Thus, life and mind are inextricably linked due to the second law of thermodynamics. Life ensures the creation of mind ensures the survival of life. Finally, all the pieces of the puzzle are ready and we can move on to the last stage of our reasoning. The possibility of having a mind of universal proportions, capable of analyzing the behavior of the entire universe. For such a mind to exist, you need a huge computer, and for this computer to work, you need fuel, that is, sources of low entropy, and in huge quantities. So far, the only abundantly located objects that fit this description are stars and their derivatives. And given the amount of calculations needed to analyze the behavior of the entire vast universe, it is necessary to constantly use the resource of stars throughout the universe. By itself, such a statement does not contradict the concept of an intelligent universe. However, if we remember that computers are inextricably linked to life and life spreads exponentially, this is its basic property. All the stars should have been captured long ago and used to the maximum. Since we do not observe this even approximately, it means that there can be no life on a universal scale, and with it there can be no universal mind. And even if it is conceptually possible in the future, the universal mind will probably become the last stage before the thermal death of the universe, and in our stage of development there is no point in talking about it. In fact, this model allows us to draw many interesting philosophical conclusions.